welcome to another PlayBASIC live video. This is the, I guess, episode 2, looking at creating a library. And last time we were working on this XML Parser library. I looked at it a bit before, but we haven't really got very far. So in our main project we've got our test code, I guess you could call it, and the other code is actually the library itself. We've got it to a point where it can pick through the code, pick through the XML document, and I don't know why it's doing that all of a sudden. By that I mean pushing the application to the back. Anyway, so this is our XML over here, which has been dumped to the console. I'm looking at the debug view in PlayBASIC if you're not sure about that. You can resize the window and it should remember them. Alright, so we're getting our tags, but we have no real understanding of the attribute fields here or any kind of hierarchical structure. So we're just skimming through finding them, and that's all we're doing. So I think we might add a bit of code to try and phrase out some attributes after one of these. I think I've realized what the rules of this actually are. I'll just make an example up here on screen. So I'll make just a comment block here. So our file can have a tag. This might be, level data or something like that. We might have in it, or we might, well, say it's a sprite. And if the sprite tag ends with its closing, I'll be referring to as bracket. I just feel comfortable as referring to as bracket. Then this tag here is a parent, a root, and we're expecting for this to have a closing tag at some point, which is the opposite. So between the two, you've got the data, whatever data this thing has, data of sprite. You might have other tags inside here. You might have a name field, for example, and to save space you could just have this. Well, I won't go into that. You could have the name between two brackets here. Sprite could be called Bill. Probably best just to have all the fields like that. Maybe it's draw mode could be in between the two tags. That kind of thing. The file we're looking at though sort of has attributes. You could have something like in here, because you could say the index of our sprite we want it to be 45. It seems a little bit restrictive really if you're going to try and do that in a file format, but so be it. Or maybe you've got, I don't know, maybe a color property in there or something like that. I'll have some color in here. Color it white, for example. So the attribute is applied, or it's not a child, it's a property of this thing here, and the name block here is also a part of this sprite here, but it's kind of a child of this, if you know what I mean. So in our Parser we don't really have anything at the moment that can deal with these kind of properties here. That's what we'll tack in today, and we'll just tack it in, see how we go. We'll worry about the quality of the code later on. Today's date, I'll just update the document here. It is the 2nd of October. I'll make it shorthand. And we'll call it version 2. I won't bother renaming the files. Quick save and a bit of a refresh. We've got our one XML load function. It loads our document, checks it out, drops the document to the console, which is what we were looking at before, and then phrases the document. At the moment, just drops the tags to the screen. But it doesn't really understand any hierarchy. So this part here is detecting the section names. And as I said before, I don't really know the format. And there's probably a lot of, double dutch in looking over the format. And we just want to get something that will get the data into memory without worrying too much about anything really. Okay, so if we're skimming through our section name and we find the divide symbol, that's the end of the tag actually. Here we're looking, if we find a space in our name, then this here, we need to evaluate, we need to check for, well, it's properties. So in other words, the tag could look like this. Example, we might have key equals data, and then the closing of that tag. This is our assumption. So what we need now is a little loop in here, just that skims through and looks for these kind of declarations. What we probably could do is we could make a bit of a shortcut. We could use an in string to find this closing bracket. Potentially there's a problem there with malformed data. If the file we're trying to read doesn't make any sense, then we might get the wrong closing bracket than we expect, and we might get weird properties or weird attributes. No, I like properties better actually. So we'll look for, I'll have a variable closing, I like bracket, in string. Our document variable holds the whole file, and we'll search from our current position that we found this character at, where is that? It's this one here actually. We want to search +1. We want to start with the next character across from it. In string is smart enough to clip this inside the search request without giving us an error. Sorry, we'll just show you the parameters there again. Now we want to look for this lovely thing at that lovely position. So we're searching document for this closing character here from this position here, and it doesn't matter if it's case sensitive or not. I probably should set that to false, just to make sure the search loop is the most optimal version it possibly can. Now closing bracket, if it finds one, so we use our example here for example, sorry, this variable here is currently pointing at this space, and we're doing a check from this character to search forward looking for one of these. Now if it finds it, it should be greater than here. If it didn't find one, it won't be. There's an error. So if closing Oh, closing bracket is bigger than whatever that was. Find character loop. Everything is okay. Else, just put a little notification in here to do. It couldn't find close of tag. I'll just put that in here. XML loader error. Just say I'll just say the same thing. Couldn't find closing It's a bit cryptic. So if it searches for it, can't find a closing tag, that goes, well, there's something weird about this tag, and we can work out something to do later on. Right now, I don't care. If we do find this character, then I guess we could just limit our searching, or grab this as a substring, grab all the attributes, grab this data here out, and then do a bit of messing around. We could probably do, like, we could grab these chunks here, and as long as they're very rigidly typed, so this might be you can have many properties inside here. For example, you might have key2 equals data2 or something. Don't know what you'd want to do, but you can have more than one of these. So we could go, okay, let's do a split on space. That's not going to work because potentially there might be a space character inside these keys. There might be a string inside the key. So be a nice quick solution, but occasionally it would get it wrong. I think what we'll do is we'll grab the, I'll just call it props from this thing here, and then we'll throw it into another function that splits them apart and like spends a bit of time actually and looks at what's going on a bit more carefully. I just realised I'm pointing at the screen there, trying to make you realise what I'm talking about, but you can't see that, can you? No. Okay. Find character loop. So from this position here, we want to get the closing brackets. We don't mind if we lose the last character, so find character loop. We'll dump this to the screen. So it will give us the props and then hopefully give us the section name after that. Hopefully. Who knows? Let's give it a go. Why is it doing that? Stupid thing. Let's have a look. Okay, PB project, we've got our properties here. We've got main equals main, which is the file name in this case. Look at the console. Console includes has got some properties on it. It has grabbed the end character there, which we didn't really want it to do. What we might do is if we find the closing bracket, yeah, we could probably look back at this character here and just check if it's if it is that closing bracket, and then we know that this tag was the equivalent line. So that's includes, is it? Or this line here. We've got this include 0 tag that has these properties, but we don't need a include 0 closing tag because we've got the close over here. Hope that makes sense. It may not. I'm sorry if it doesn't. Yeah. So there's no child data of this include here. It just has the properties of include. Whereas include tag here has these properties, has the main property variable, but also has the children include 0 and include 1. This can be infinite. You can have include 0 could have its own. Yeah, or it could have, you know. So we've just got to be careful we don't code ourselves into a box. Alright, so if we find that if properties here, yeah, we probably do need to handle this in a particular way, don't we? Like we might need some flags to go, well, to tell us what to do with this section name and these attributes, and is it are we expecting a closing tag sometime in the future or not? But at this point, we'll do a little bit of a test on if mid document closing bracket. Now I know that this can never underflow, so I can just do a direct comparison. Yeah, just for now, I'll just put in here tag closed. We'll probably just have some property there eventually, and if we do not see that there, we can move closing bracket back one, and it should not give us that in our output. I hope so. How are we going? Looks like it's worked, doesn't it? Simple logic. Alright, we'll probably make a separate little function here, otherwise we're getting too messy in this main. I don't like passing these strings in and out, and there's a reason for that, because when you throw strings between functions, they're generally copied between the two, which is not great. Okie dokie. Let's make that function to decipher our properties. We could have just props up here, couldn't we? So at this moment our section and property names have nothing. We could get rid of this thing here, and we could just display our section name and then our props if there's any properties of this section name. Okay, so PB project has this property here, includes have this property here. Its tag is closed, so it doesn't need. Oh, sorry. This one here is has no children, so that it's misleading there where that print statement is actually occurring. We'll have another little variable at the top here. Section name flag. I don't know what flags we actually need, so I'll just have a very simple flag here. If it's 0, the assumption is the section is a parent, and if it's not that, then we don't need to add a parent. So I can just tag that out. I'll just print that, the status there, so we can see the data coming through. Very hoarse. That seems to be correct. So PB projects, got it, which is the our attributes are here, and we don't have a slash bracket at the end, so we are expecting another closing tag of this later on in the document. So all of this stuff here is inside PB conceptually. Often it's easier if you indent this stuff really deeply. And so you go, oh, well, that's easy to see. Yeah. Does that make it easier to sort of see what's going on? So PB project has this stuff, these properties here, these sets of tags. I don't know what the language is. I don't really use XML much. In fact, hardly ever. Most of the time when I need to read a document, I just need to read one little section of the data, so I just load the file in and just literally just search for what I want, grab it, pull it out, and throw the rest away. Okay, so if we've got properties, we best actually do something with these properties. If we find closing bracket, then we actually need to set the outer loop counter there and then to make sure it skips over. It's not searching the properties of here. There is a potential error there if you do notice that. Like we should probably do this. I know it's a kind of double up there, but so if closing bracket is bigger or larger than else and if, and that should help us avoid a possible deadlock. I will refactor the code, by the way. I know it's pretty appalling. Okay, let's get stuck into this a bit of code to phrase these properties out of this string. Just check that's still working. Seems pretty decent. So we want to decode these things in here. For that, I think we'll actually make one subtle assumption. We'll just go, well, I'm pretty sure that these assignment characters here have to be there, so I'll use those to rip it apart. Make a bit of a function down the bottom, another little private function. Our private functions are called ZXML, so they appear at the bottom of our include list over here, just for that reason only, really. What was it doing? Oh, decode props. We'll give it props as a string in. We don't know how this is we're going to store this, but at the moment we just want to phrase them and break them apart. For loop equals 1 to, well, 1 to the length of props. I don't like to capitalize my variables. The IDE has a mode where I can do that for you, but it can be a bit fussy. Like I can actually hang the IDE at times. Not a good thing. Okay. We could do the search ourselves. We can search through and find the key and then look at the next one. We might just do something a bit simpler. Let's go here. So I'll just grab that string again, that comment up here we made before, just so I can visualize what I'm sort of thinking about. Okay, so this props string here is going to contain this data here, and we need to break this up into at least two things. We need to get the key names out and the data they have out as well. What I think we'll do is we'll do a search for equals. Equal character, or equal position, that'll do. We'll do an in string, we'll do props, and we'll do of equals, and then we might hang this a bit. Okay, if we search here in equal position, if equal position is larger than yeah, we'll call it last search pause. Make that a local last search pause. This can be last search pause. And for initially we'll just set this to 1. Sorry, 0. So if it finds an equals, we are golden. It'll do what our code in here. So if we search forward, we find an equals here. We kind of need to know, well, we could just assume that what's on this side here is key. So we could just go key mid of props, and we want to look at what was I looking at? Last search pause. We want to grab from that position there, and we want to go to equal pause wise. I got a feeling there's a bit of a logic problem there. We won't worry about it at the moment. We'll just print the key out, just for our own clever sakes. So once we find the equal key, the equal character I should say, we need to find this data block here. We could do a mid if it's not the next character after that. We could do a search. I'm guessing that most times it's going to be that character. Equal position plus 1. We want this. Are we looking for? Oh, this is character 34. We want the ASCII 2 value of that. That's the quote character, by the way. Okay, so we've found, if we get to here, we found the quote, this quote, and then we need to find the end of the quote to work out the data. I think what we'll just all have Oh jeez. Quiet position equals equal position plus 1. So we're searching at quiet position. We found it there. We're using mid dollars. I'll just print that out as data is a keyword in PB. It's actually a way you can store data inside your programs. It's a bit of an old one. Quote position minus. Oh. Last quote point or end quote position. End quote pause minus quote pause. Once we find that initial quote, we need to do another in string. Yeah, that's the trouble with writing stuff off the top of your head. It's a bit of a mess. Character 34. We're searching for this thing here, and if we find it, what's the variable? Quote position equals that. We want to search from the starting quote position plus 1. Otherwise, it will just return this initial quote. We want to search from here onwards until we find that one there. So if end quote position is bigger than quote pause, then we've got our data. If it's not, something weird's happened and the world is ending. Well, you know. I'll do a bit of a compile just to see if that's actually going to actually compile, and it does seem to run, but we definitely aren't doing anything with it at the moment. I often like to put just a print statement at the top of these things, like when I'm using sort of text output like that. I just like to get some idea of right. So that's the properties there, and we'll just have a little. We'll drop this in here. If the length of props is bigger than 1, then try and phrase it. We'll see how we go. Who knows? Well, it's not really phrasing, is it? Kind of skimming through. Okie dokie, so we've got our first, our key token, yes, but we don't seem to have the correct data token. Main here, and main is, yeah, it's not finding main. How dare it? How dare it do that to us? Okie dokie. Probably just made a bit of a bloom in here somewhere. I know that's working now actually. I'll put key and I'll print the key and data side by side. So always print them because I just want to make sure of what characters we're actually getting from it. I think we're getting more characters than we actually need at some point. Okay, mid key looks like it's correct. Mid at the quote position here. Equal position looks like it's okay. Equal position. I'll put a little print there. Found. Start of data. Just kind of want to see that on screen. Now, okay, found start of data. It's printing the same thing because we are printing the same thing. Data, end quote position, props, quote. Getting to here, we're finding doing it in string. There we go. Terrific typo. We just missed the spelled the little props variable incorrectly, and in implicit mode it won't stop and bark at you and for those. Let's have a look. Okay, so we've actually got our version key attribute seems to be correct. We've got our data almost correct, but not quite. When we're grabbing the characters here, it's not quite what we want. So that's okay. We could do a trim of this, I guess. Yeah. I think search position should start from character 1. We're always looking for. It should be impossible for this to be character 1. If it is, there's something malformed in the file. That's my assumption anyway. I don't know if it's correct. Wouldn't have a clue. Let's have a look. So we've got found start of data. Yeah, 0 and version. Sorry. When we grab our properties, we're actually grabbing the wrong character too far. So we could grab. We're grabbing from where the space character was to there, so we don't really need that. And a bit of extra nonsense in there, in our little grab there. So there we go. I wish it would stop doing that. I don't know why it's doing that. It's unusual. Looks better. So from PB project, we've got our key of version. Our data of that is 1. The type of data that these attributes can have is obviously it's numeric data and strings. As for what else, I don't know. It might be encoded data for all I know. I have seen files that are, I think it's like base64 encoded as well, which is a bit of a weird one really. If you're going to be storing binary data inside your text file, like compressed binary data, what's the point of storing it in text to begin with? Seems a bit silly. There's a few optimization situations here. I've got a bit of course this only grabs one of them, the first property. What we want to do is actually do this in a repeat until. Run it again just to check it is actually still working. Console, right, so that's our properties. We've got key of version and data of 1 inside here, or after that I should say. So we are actually picking out all the data from it, as far as I can tell. We're not getting all of our extra properties here, like down here for screen, where it's just got the dimensions, just screen here. It's got a width property, height, depth, etc. So we need this to do a repeat until. So we're going to do a search. Yeah, so I want this thing to repeat until well, actually you just have a do loop there, and if this ever fails you just exit. You don't really need to repeat until. Here's what I was thinking before about a possibility of having a deadlock. Got to make sure that we set actually, once we find this new equal symbol here, we set our last search position accordingly. If we found the next character here, the last search position here is going to be end quote position. If it's not set accordingly, it's going to end up hanging. So end up just sitting in one spot, just searching and searching and searching. So if it does find equals, we want to set. We did find the next one is the quote. We found the closing quote. We're happy to set that to search from the next point. We want to search from here +1, and we'll do it. We can't do a continue from there, can we? If I do a continue, we're not going to print out our data. Print keys. Horrify people. What I'm going to do here. Oh, look out. They just don't care. Okay. Yeah. Okay, so if we didn't find the closing quote, we still need to deal with this thing here. We don't want it to keep searching from here. We want it to push quote here. So this time, if it's found the first quote but not the second one, it's going to search only from after that first quote position. It really should break out there actually. Yeah, that's an error. To do error missing closing quote, and we'll just break out of this loop. Sorry, we'll use exit. Oh, back's killing me. If we didn't find the quote here, we really need to do an in string to find this initial quote. I'm hoping that yeah. So that's kind of our. If we get to here, we're in a situation where our equal character and our first quote aren't beside each other. It's possible that people do this. I don't know. You know, I don't know if that's commonplace or not, or if that's legal in this format. It might be, it might not be. Which is the reason why we should probably trim these. When we get the key here, we probably should trim. And that will pull any leading spaces or closing spaces out of it. Data, I'm not quite sure we should do that because there might be space data. You might actually want to have spaces in your text. You might actually have you know, hello world as your data with spaces in it. and if I'm trimming them off, then it's going to return just this part and not this other part for some reason. Like maybe you want that, I don't know. As I said, I don't know. Right. We'll give it a go. See if it hangs or not. Seems like it's working. So for this one here, our attributes are we've got a main variable visible as 1, integer of 1. Yeah, seems like it's working okay. Yeah. Alright, this might wrap up today's continuation of our messy XML reader. Hopefully you can sort of get what we're doing here. What we might do next time is we might actually try and, now we've kind of picked through the file, we might start trying to store it in some sort of hierarchy that we can access with some, get. We'll make a function to grab the data we want from it. Hopefully you found that interesting, and I'll catch you next time. Thanks for watching, and bye.